So good morning one and all. So let us start today's class. So before proceeding further, let us discuss what you have done in the last class. We have discussed the neural network. So that is also called as feed forward neural network. So this is the neural network. Now for example, here I have taken how many levels? 3 levels. Okay. Now, so the first and foremost level is called the zeroth layer or levels or layers. So which is having only inputs. How many inputs? N. So we have here how many L minus 1 hidden layers, which means in this case 2. 2 hidden layers are there. In each hidden layer we have N neurons. Each hidden layer has N neurons. Finally, this is called nth layer, which means this is third layer. So in this third layer there are k number of neurons, not n, k number of neurons. Okay. Now obviously we have for every neuron it is split into two parts. Correct? So the first one is the pre-activation AI and the activation HI. So what is AI? It is the weighted aggregation. What is HI? HI is the generally a non-linear input, non-linear output. HI equal to some function g of AI. Correct? Now how to calculate AI? I told you it is a aggregation of weighted sum. Okay, for each and every neuron. So we have to calculate these two values. But here, so AI, HI are vectors. Okay. Now here A1 and W1. W1 is the weight. A1 is the pre-activation. H1 is the activation. B1 is the bias vector. Okay. So let us write the dimensions. What is the dimensions of X? That is input vector N. So what is the dimension of A1? A1 dimension. So if there are 3 layers, A1, A2 dimensions is dimensions are what? N. W1, W2 dimensions are N cross N. Okay. So B1, B2, H1, H2 also having dimensions, that is N. Otherwise here N equal to 3. You can also write 3. So what is the dimensions of H3? That is K. Okay. A3 is also K. What about H3? Okay, W3. W3 is N cross K. Okay. So here W3, A3 and B3 are the connections between the last hidden layer and the output layer. Now finally we call HL. Okay. A3 is also called as AL. This is also called as AL. H3 also called as HL. Okay. Because we have 3 layers in this case. Now, so this is about the schematic of the neural network. So W1s are matrices. W1, W2, W3 matrices. Remaining are simply vectors. Okay. So these are all things. Now how to find out the pre-activation layer? This is how we find out. Okay. So this is example. Clear? As I told you, so we have a activation layer, that is H equal to G of AI. G is called the activation function. So we will see some examples for the activation functions like logistic and linear. Output activation function is O. Okay, so this is what exactly you get. Finally, this is the HL equal to O of AL. O is called the output activation function. Now this is the schematic for the deep neural network. First we have a data, okay, xi, yi's. So obviously the data is, in this data, xi and yi are having some true relation between them. Okay, now we'll go with the model. This is what the model is, and we need parameters theta, that is w1, w2, wl, b1, b2, bl. What are they? Their weights and biases. Now here we use obviously the same gradient descent but with a back propagation. So we'll discuss this later. Now here what is the objective function? Like this. So you can say L of theta here. So this is what the objective function, which is the sum of the squares of the errors. Okay. Now we have to find out the minimum L of theta. Okay. Now, so here I have written the proof for the output activation layer. How you get H3 equal to this much? Okay, you can go through this. Step by step I have written. Okay, so coming to today's class, already we have studied the gradient descent algorithm. Okay, so here what is the algorithm? What does algorithm say? It says that we should move in the direction opposite to the gradient. Okay, that's what you have done. So we have started with some iterations. We are going up to 1000 iterations. Now here what are the parameters we are dealing with? Actually, in the previous classes we have started with theta as w comma v. These two parameters we have to learn. So we have initialized these two parameters, and we are doing these iterations. Now here, so we are updating the weights and biases in these iterations. So we are moving in the direction opposite to the gradient of the weight and the bias at particular iteration, isn't it? Now this can be written in the simplest form like this. Okay, like this. So theta of t plus 1 is theta of t minus eta delta theta of t. Okay, so what is we writing? Theta of t plus 1 equal to theta of t minus eta. This is called scaling factor, which is very small, and it is also called learning parameter. So delta of theta t, not theta of t, theta t. Obviously, so according to the algorithm, we are moving direction in the direction opposite to the gradient of this theta. Okay, so how to find theta of t? So how to find this gradient of theta of t? So it is simply the partial derivative. Theta of t here is having two parameters. What are they? W and b. So at particular iteration, what do you write? So delta L of theta by dou L of theta by dou wt. One more thing is dou L of theta by dou bt. Okay. Now, so this is the how we find the grade of the theta of t. So it is very simple, because the theta is having only two parameters, that is w0 and b0, or w and b. Okay, but in this case, in our neural network, what is theta? What are the parameters we have to learn? How many? All these parameters we have to learn. All this. What are they? w1, w2, w3, a1, a2, and beta1, b1, b2, b3. So obviously we have to learn how many parameters in our deep neural network. So we have to learn how many? So theta is w1, w2, so on, wl, as well as b1, b2, so on, bl. These many parameters you have to learn. Obviously, in the same algorithm, we have to replace theta with like this. Okay, so still we can use the same algorithm. to learn the same parameters. W1 to WL, B1 to BL. These are weights and biases. Okay. Now this is how the algorithm changes. So now we have to initialize all these parameters instead of W and B. In the previous case, theta was initialized with what only? Theta naught equal to W naught and B naught. But here you have to initialize these many parameters. And everything is same, but only thing is how to calculate this del of theta of t. Okay. So it is very tedious task because we have to calculate so many parameters, so many partial derivatives. Okay. So this is about the algorithm for the neural network. The algorithm same, only thing is the number of parameters which need to be calculated is increased. Okay, that's it. Now, anyway, so always, so we have to deal with some output function and loss function. What is output function? O. What is loss function? L of theta. So these parameters we have to learn. Why? Because here we are taking the gradient. What is the gradient now? Partial derivative of L of theta with respect to the weights. So this L of theta is need to be calculated. Okay. Not only that, at the output side, we need to design what is the output activation layer. That is O. So how to choose the loss function? We have to choose the loss function such that it minimizes the loss. Okay. Now, yeah. So consider this example. Okay. So in this problem, the input is an n-dimensional vector. Okay. So input is about a movie. Okay. So who is actor, who is the director, what is genre, so many things. We are taking n features of the movie. Now we are predicting only 3 values. What are they? IMDb rating, critics rating and RT rating. So input is n-dimensional, output is 3-dimensional. Obviously, so the output is belongs to R3, yi. Okay. So the prediction is of only 3 values. So from n vectors, we predict 3 vectors. Okay, vector of 3 values. So it is having L-1 hidden layers. So everything is same. Now here yi is R3. Okay. Now what is loss function? Obviously how to calculate? So this is the square of the error. Sum of the square of the errors. So we are taking I equal to 1 to n. So okay, no problem. So I equal to 1 to n means n input vector and j equal to 1 to 3 means output is having only 3. You have to predict these 3 values. So for that we have taken the sum of the squares. You will get the loss function. Okay, but here, okay, so what is the output function? Loss function we have calculated. Okay, the formula just now explained. Now what is the output function? Output activation function. Okay, so can it be a logistic function? Can the output activation function be a logistic function in this example? Okay, here remember the output is having real values, not the Boolean values. Okay, suppose not only Boolean values, it is the output values are more than 1. 7.5, 8.2, 7.7, they varies from 0 to 10, let us take. Okay, so can you choose a logistic function as output activation function? No, why? Because if you remember, the logistic function minimum value is 0, the maximum value is 1. So the output of the logistic function can never be more than 1. Obviously, but we have to predict the values which are more than 1, that to real values. That's why the logistic function will not work. Because the output predicted value should be a real values between 0 to 10. Need not be 0 to 10, it can be any unbounded values. Now in such cases, the output activation function can be a linear function. Why? Because here we should not have any bounds. If we choose the logistic function, it is bounded from 0 to 1 only. But here we have to predict the values which are not bounded generally. In that case, we have to go for a linear activation, output activation filter or function. Okay. So what that can be? So that can be something like this: omega naught into some AL plus B naught, B0. So you might have seen already. So for the remaining percept and all those things, what we discussed. What is the output? What did the output? Wx plus B. This is where taken summation. Otherwise we written W dot X plus B dot product. Same thing I meant, sir. They are also linear, they are also linear. So if at all the predicted values are unbounded, we have to go for linear output activation filter or function. Okay. So in that cases we can go for linearity. Now let us take some other example. That is a movie example. Not only that, so in the previous movie examples we have discussed whether you like it or not, like or dislike. Okay, whether you like it or not, that is what the decision we have to take. But here, so it is not one dimensional, it is 3 dimensional. Okay, because we are predicting the 3 values which are real numbers, which are not bounded. Okay. Now let us take one more example. Suppose here, so let us go with the distributions. We have to go with the distributions. Suppose, so we have an experiment of choosing a ball from the urn. Okay, so these are the probability distributions of choosing the red ball, green ball and blue ball. Some example. Okay, what are they? So these are the actual distributions. What are that? What are they? 0.35, 0.25, 0.35, 0.25. Obviously remaining should be 0.4 because the sum should be 1. These are all probabilities. Now what is the predicted distribution? This is actual or true. What a predicted distribution is? What is that? 0.25, 0.45, 0.25, 0.45 and 0.3. Obviously there is a deviation from actual values. There is a deviation between them. Okay, so there is error. Obviously these are the actual values, actual distribution of probability distribution. This is the predicted probability distribution of a certain experiment. Now there is a deviation or there is error. How to find out the error? How to find the error? Obviously what do? You take the, so let us call some other values here. Let us call this is P, this is Q. P is the original true or correct probabilities, Q is the predicted probabilities. Now how to find loss function? So generally you take P minus Q whole square, otherwise Pi Qi whole square. I varies from 1 to 4. This is the loss function, isn't it? But so the question is, okay, so that is one more way of looking at the loss function. Now let us take one more example. Classification problem. What is that? So we have to classify an image into one of k classes. What are they? Now this is the classification problem. Now we have to classify this image into one of the k classes. K means how many classes here? 4. Either you classify it as apple, mango, orange or banana. So in this figure, what is the figure is apple figure. So that's why this is the true prediction, true values or actual values. So it is also distribution. Why? Because it is called one hot function. Why? Because only one of the elements will be 0, and they are just like probability distribution. Okay, these are the true distributions. But so what can be another distribution? So I think this is which one is 1? Apple is 1 means what is the true distribution? 1 0 0, right? Okay, so let me take this is 1 0 0 1 0 1 0 0. Now what I predicted? These are my predicted distribution: 0.3, 0.1, 0.2, 0.4. Obviously there is a loss or there is a deviation from the true values. Now, so the question is, again we can use the squared error loss to capture the deviation. So can you think of any better function in case of probabilities? Okay, let us see. So instead of going for the squared loss, can we have any better function which can represent the deviation of the probability distributions? Please remember, here the problem comes to probability distributions. Whenever a true and predictions are having the probability distribution, what is a better loss function than this squared error? Can we have any other function which can define the deviation properly other than this loss function? We need a function which can define the deviation accurately. Okay, so that is what we need to find out. Okay, now so let us get into the some other topics like, okay, so what is information? We have studied these things in the information theory. What is information? If any event occurs, it gives some information. So if event occurs, the information we get from that event is given by log of 1 by the occurrence of that event, probability of occurrence of that event. Obviously, information is always inversely proportional to the probability of occurrence. These things already you know. So the information is, what is information? That is nothing but minus log of probability of occurrence of that event A. Okay, this is information. Is it okay? Now what is the entropy? H. Entropy is average information. What do you write? So the probability of occurrence of A into information of A. I mean, this is what we have, average. So if you take this, what is this? Minus the probability of occurrence of A. What is IA? Log of PA. This is entropy. It is a measure of uncertainty, or it is the average information per symbol or per source symbol. It is called entropy. Now what is the cross entropy? The new term is cross entropy. What it defines? So we have two distributions, P and Q, PA or QI. So this is the true distribution. This is the predicted. Now, so what is the better way of writing the cross entropy? What do you write? You write this as summation Pi log Qi minus. So now this is a predicted probability. This is the actual probability. Pi into log Qi. This is called cross entropy. So let us define this term, cross entropy. Please remember, these are the true or actual probability distribution. This is the predicted probability distribution. Okay. Entropy, cross entropy. Now, so we can use this cross entropy to define the deviation. Now this is better than loss function. Okay, so whenever we have a probability distributions for input and output, so the better way to go is with the cross entropy rather than going for the loss function. How it is better? Let us see. So that is the last function we will discuss. That is the what do you call cross entropy. We will discuss later. Now, so next comes what comes next? Yeah. Now, what is the output layer? Output activation layer. In this example, in the probability distribution example, this is the classification problem. You have to classify the image into k classes. Okay, it is a one hot function, just like the probability. If sum is 1 and all are positive and all are less than or equal to 1, 0 to 1, within 0 to 1. Now it is a classification problem. You might have studied these things in your courses. It's a regression problem. Now, so in these cases, what is the better output activation function? Okay. Now, so here it is called softmax function. What a better function for output activation filter function? Softmax function. So, can we use logistic or sigmoid function here? The question is, can we use the logistic or sigmoid? The problem with the logistic is, okay, the thing is it lies between 0 and 1. It is also just like a probability distribution, but the problem with this is the sum of all the values is not equal to 1. This is called logistic. We cannot use logistic for output activation function in the case of classification, for a classification problem. Why? Because if the classification is giving the probability distributions, the logistic function may give the values between 0 and 1, but the sum of all the values may not be equal to 1. Because it is a non-linear and area can be more than 1. But so in our cases, in the distribution case, sum of all the values must be equal to 1, just like probability. So logistic is not opted. Now we go for the softmax function. So what will happen here? So in the softmax function, what we do here? Like this. So these are the some output layer values. Let us take AL. Okay. So remember, HL equal to some output function O of AL. HL is nothing but y cap or f of x. Now what we do is we take this function as softmax function. What it will do is it will take all the elements of AL. What it will do? Suppose you have these values, some 10, 20, 30, something like that. So what they will do? First, they will take e to the power of 10 by normalization. What is that? E power 10 plus e power 20 plus e power 30. This is for first element. Next, e power 20 by this same denominator. Now here what happened here? In the denominator, this is something like normalization. Okay. Suppose for second one, what will get? Obviously e power 20 by same denominator. Third one, e power 30 by same denominator. If you add all the values, you get what? E power 10 plus e power 20 plus e power 30 by same this denominator, that is equal to 1. So these are being normalized in the denominator. What happens? All the values are less than or equal to 1 and sum of all the values is equal to 1. It is following the probability norms. Okay. Now it is called softmax activation function, that is for output activation. Okay. Now this is the equation. Don't get confused with the equation. Very simple. From AL we get the predictions. Now these predictions, they follow probabilities, a distribution. In this example, you can calculate the values. All are having less than or equal to 1 value, and if you sum of them, if you add them, you get 1. It is a distribution now. It is a predicted distribution or predicted probability distribution by using the softmax function. How it is defined? Like this, or in the best way you could write like this. Okay, right. Now, so I told you for loss function we don't use the sum of squares, we use the cross entropy. Okay, so this is a cross entropy. We have k class classification problem. So now L of theta is, this is a loss function only, but it is not defined as the sum of the squares of the error. It is defined as the loss function. I'm sorry, cross entropy. What is that? YC log YC estimation minus. Obviously, you know these things. So YC equal to 1 for the true class label. Correct? You know already. Let me go back here. If you take the, yeah, so only one of the outputs is 1. One of the values is 1 for the correct label. So if C equal to L, if the label is correctly matched, YC equal to 1. YC equal to 1 if C equal to L, which means if C is not equal to L, output is 0. I mean YC is 0. If YC is 0, the entire sum is 0. Now, so the entire sum is non-zero if and only if C equal to L. If C equal to L, what happens? What happened to L of theta? So all other terms are 0. Why? Because it is 0 otherwise if C is not equal to L. If C equal to L, YC equal to 1. Okay. Obviously, this is summation is can be removed. You can write minus log YL cap. This is the your loss function. It is very simple compared to the sum of the squares of the error. Correct? Now the classification, for a classification problem, the following is objective function. Yeah. So what is this? L of theta, that is minus log of YL cap. This is the what we need to minimize. We have to minimize this loss function. So here the loss, for a classification problem, the loss function need not be a sum of the squares of the error. It is a cross entropy. It is perfectly captures the deviations from the true probabilities to the predicted probabilities. Now this is what the objective. Minimize L of theta or maximize minus L of theta. Otherwise, minimize this minus log YL bar or maximize log YL bar. Okay. But what is YL? So let me write here. What is YL cap? YL hat. What is it? These are the predicted probability distribution of correct class. Please remember. YL cap is, YL hat is predicted probability distribution of correct or true class. L is a true class. Among k classes, L is a one is true classes, right? That is L. Is YL is a function of theta? Yes. YL cap is a function of theta. Okay. So again, the problem boils down to theta again. So, but theta is a function of what? YL is a function of theta. Sorry, YL means YL hat is a function of theta. But theta is a function of what? Weights and the biases. W1, W2, so on, WL. B1, B2, so on, BL. The only change we have done is, instead of going with the sum of the squares, we are going with the cross entropy because it is fine for the classification problem. So this is for 3 L equal to 3. I have explained the this function in the last class. Okay. Now, so log YL cap YL hat is called the log likelihood data. We have discussed these things in ADC also. Log likelihood function. Okay. Now the problem is here. Okay. So we have to minimize log of minus log of YL hat, or you have to maximize this log of this. You have to maximize log of this quantity. So, but this quantity depends upon theta, but theta depends upon these parameters, all weights and biases. So this is called log likelihood data. Log likelihood data. Now, so I told you we have deal with the output activation function as well as loss function. So if the output is having real values, I have told you example of movie where we are estimating 3 parameters. What are they? IMDb rating, critics rating, and some RT rating. In that case, what is the output activation? Linear. Why we have choose linear? Because they are unbounded. They are not between 0 and 1. The ratings, all those things may not be between 0 and 1, or they may not be bounded always. So if that is the case, we go for linear output activation. The last function is the squared error. Okay. So if the output contains only real values, these are the best choices for output activation as well as loss function. So if the output is having the probability distribution, what is the best activation, output activation function? Softmax. And what is the best loss function? Cross entropy. Okay. So this table is very, very important. It depends upon what output is. If it is a probability distribution, these two are preferable. If it is real values, these two are preferable. Is it okay? Now we have discussed about these two things in detail in the next classes. Softmax and the cross entropy. Okay. So remember this table. This is very, very important. Correct? Okay. Stop here. Thank you.